So hello everyone, welcome to the workshop for the 2D top-down shooter. I'm just gonna be going over very basic level stuff in order to make a semi-functional 2D shooter. There's a lot of things you can add to it. I'll explain at the end, but for now, this is kind of what you're gonna be making. If you have any questions, please feel free to post them in VC Tech Chat, and either me or Luke will answer them for you. So as a quick overview, the idea is like you can move around, you can look around, you can shoot, and the enemies can die. And if you get hit, your game's over and everything stops, right? That's basically what we're going to be looking at and working on for today. So let me just pull up the Unity real fast, the fresh project. All right. So I'm gonna be explaining this in more of a build on to what Luke has basically explained with his Unity tutorials. So if you were there for that, I'm gonna kind of build off of that. If you weren't, just ask in chat and I'll clarify some things. All right. So first things first is that with this 2D top-down shooter, we have a few objects we want to worry about. Right. We have our player, we have our bullet, and then we have our enemy. Those are the three main entities that you'll see in the game, play around with, and kind of like use as in the editor, right? So the first thing we want to make is our player. But before that, I want to show you this. Since everyone here has been basically working with 3D graphics, this is kind of new. This is a 2D graphic style of Unity. So if you create a project, you can see there's a 2D option, and this is what winds up being that option. So in the 2D scene, you can see like it's really flat. It's basically what you imagine a 2D game world would look like. But I want to explain a little bit of a caveat. With Unity in 2D, it's actually this button over here that's making your game in 2D. So if you click this button, you kind of have a 3D overview of what you've been seeing with the tutorials in the past. And this is kind of what your 2D world is being made into, like a 3D space, but in 2D, right? Your camera also has a few things different with it. Instead of viewing the world as a 3D world, it's viewing it in a 2D world. So if I create a quick 3D cube, you can see that in the game view, it's flat, right? It's flat. It looks like a grayish, dark gray cube. And plus 2D, and moving into 3D world, it's basically just a cube. There's no lighting or anything, so that's why it's dark. But it's basically just a cube. But in your game screen, you'll see it as a 2D image, right? So it's gonna be flat. It's gonna have no depth to it. It's just gonna be just a 2D image. So that's one thing to just think about if you're working in 2D. Some of the caveats, some things you have to worry about when you run into problems with maybe a 2D, 3D thing. But we're not gonna run into any of that today. It's just gonna be straight up just developing 2D. So first things first, how do we create a player in 2D? So Luke basically explained that game objects are your thing that controls and stores everything. And I believe he did also make a 3D player controller. So we're going to basically emulate that in our 2D game. So we have our empty game object here. We're going to rename this to player. We're going to add a component. And actually, before I add the component, I'm missing one valuable thing, our asset, right? So our asset for a player is going to be in the zip file I provided. It will also be in the description of the video if you're watching that. So I'm going to create a new folder, call this our sprites, because these are what the assets are. These are just sprites. And then I'm going to add all the assets into the folder, just so we have them. So now we have all our assets. We have our gun sprite, we have our ghost sprite, we have our cog happy, that'll be a bullet, and then we have a background. So first thing we're gonna focus on is the gun sprite. The gun sprite will be our player. We're gonna just be a moving, walking, shooting gun, right? Something very simple. And all these sprites, aside from Cog Happy, were provided by people on the announcement. And when we submitted that form where you can submit assets and everything, all these sprites came from there. So if you're interested in submitting any assets, go ahead and use that form, submit there, and we'll use it in the game. So anyways, we have the gun sprite. So this gun sprite, we're just gonna drag it onto our player so we can add it to the scene and kind of look at it. And you can notice if I turn off gizmos, which turns off the camera icon, you can see the gun sprite's right here. And it's a bit small because this one block right here is a unit, one singular unit, and it kind of is like maybe a quarter, an eighth of that. And we kind of want that to be bigger. Since this is going to be our player, this could be our main attraction. Since if you look at it in game, our players should be very small. We kind of don't want that. We kind of want a big player. So how do you do that? So basically, you can go to your gun sprite image right here. And in Unity, it has something called pixel per unit, right? So basically, what pixels per unit mean is a way for you to take your image and scale it accordingly to 1 unit in Unity, aka pixels per unit. So right now, this value right here, it says 100. So what this basically means is that every unit, so every block of here, so you can think about this as one block. For this one block, it has 100 pixels by 100 pixels in it. So the length of it will be 100, the width of it will be 100, the height of it will be 100. This is a 100 by 100 kind of like image, right? If you kind of incorporate that into units. So what we need to do to make this bigger is that our image is actually rendered or a 32 by 32 image. So we want to expand that so we can fit 1 unit. So what we can do is, since it's a 32 by 32 block of image, we can set, instead of 100, we can set a 32, press apply. And now we have a 32 by 32 sized gun. Very fun, very simple. And we can drag, and you can see like it perfectly fits the box now, right? Let's put that back. So actually, you can notice one thing. It's not all perfect right now. There's some problem right now with it. You can see how this is supposed to be a pixel art, and it's kind of blurry. And you, with pixel arts, you don't want blurry art, right? So what's happening here is basically that it's applying a anti-aliasing. Oh, Merc. Merc, you unmute yourself by accident. Thank you. So what's happening here is basically this gun is being anti-aliased. So if you know anything about anti-aliasing, it's basically the idea of taking a few pixels and making them smooth, right? So if you have an edge of pixels, which will be just like staircase of pixels, it'll make it like a smooth line. And that's something we don't want in our gun. We want very, very visible pixels, right? Each pixel should be 1 pixel and nothing but. So what's happening is that this filter mode right here is actually our problem. It's applying that anti-aliasing to it, and we just want to disable it. So we can just set it to point, no filter, and press apply. Oh, there you go. Now it's visible, now it's perfectly pixeled, but there's still no problem with this. If you see on this pixel art, if you look at the original image, there's weird colors that appear. You see these lines of colors that aren't in the actual image. Well, that's part of it. That's the compression Unity adds onto it. So we need to disable that too. So what you can do is in this gun sprite, there's a compression field, set that to none, apply, and then all of a sudden your colors are perfect basically, right? So now you got perfect pixels and perfect colors. Nothing more, nothing less to it. So now that we have our gun sprite, I just want to reiterate this gun sprite should be under player because this is just its own thing just to represent what the player is. We need to do a little adjustments of the positioning. So I'm not sure if Luke explained this to you, but I'll reiterate this to you. When it comes to positioning objects in Unity, there is many ways to think about it. First way is your root object, which is basically the object that has no parent. So say main camera is a root object and player is a root object. These objects, these value of positions define a actual world value. So what that means is that if I move player to, let me turn on gizmos again so I can see. If I move player to 0, 0, now 0, 0 is not there. Let me move the gun sprite so it doesn't confuse you. There we go. So player 0, 0 is right here in the center of the screen where 0 is in the world, right? Now, if we add the gun sprite to this, you can see it already has some predefined values, positions for its actual position, and player is right here. Actually, I'm going to add something just so we can visualize where the player is. There's a button right here where I can select the icon just to visualize that for you. So you can see players at 0, 0, gun sprite is not at 0, 0. If I drag gun sprite under player, now you have nothing changed, right? So you have this still in the same positions as it was before, and player still at 0, 0. But if we move player one x to the right, now gun sprite, it's moved to the right, but you can see position negative 1.41. That's the same position it was before we added to the player object. So what's happening here? Basically, you have a world position, which is your player. It can be defined as your player. And then you have your local position, which is what the gun sprite is referencing since it's under the player game object, right? So what is a local position? A local position is basically a position based off of another position, right? So this position right here is actually not based off of the world position, but it's based off of the player position. See, the player's at 1x, and this is at negative 1.4x, but it doesn't make sense in terms of the scheme because negative 1.4x would be around right here. So we can visualize this even more. If we take it out, the value changes. Now it's negative 0.41. See that one difference you get from the player, that 1x of difference changes the values and everything. And when we take the gun sprite out of that position, it goes back to a roll position. And now we have a more standardized value you can work with. So I want you to keep this in mind when you're working with multiple layers of game objects. Always make sure that the actual object is in the actual position you want it to be. Since right now we want this game object to be at our 0, 0, we have to set all this to zeros. Right? So now the gun is perfectly centered around the player, right? And then we can move the player back to 0, and now we have our player gun. All right. So now we have a gun. We need to define a few more things. So with a gun, with our player, we kind of want to make sure, hey, if the player gets hit, how are we going to detect that, right? So we can just add a quick, on the player game object, add a square box collider, box 2D collider right here. So the box 2D collider will basically be our 2D version of our 3D collider. So make sure when you use a collider, instead of using the 3D colliders or the colliders that don't have any dimension named to it, instead of those in 2D space, you want to use the 2D colliders, right? Since we're transforming from a 3D sense of unity to a 2D sense of unity, every component, if it has a 2D replica of it, you have to use it, right? So now our player is a collider. We want to adjust this a little bit, so we can click Edit Collider, and we can just move this closer to the gun and move this closer to the gun, and then we have our collider set, right? It's that simple. So with this collider, this will basically allow us to test, hey, if the player gets hit, we die, right? So what do we do next? We want to create our script for the player. So the script for the player will basically move the player, make the player look around, and also shoot a bullet. So what I'm going to do is create a new folder at our assets folder. Call this scripts. Enter the folder. Create a new C# script. Call this player controller. Press enter. And now we have our script for the player. And before I move into the editor, I just want to move this into the player game object. So we know it's there and we don't have to go back to it. So there we go. Let's open our player controller script and start doing a little coding, shall we? Let me just open this. There we go. Now, I just want to reiterate, I am using Rider. It's free for Rutgers students or students in general. So if you want to use Rider, go ahead. It has a lot of nice features. But if you're using anything else, like VS Code, Visual Studio, that'll work too. But it might look a little different. So just pay attention to the text. Don't really pay attention to like the small event function stuff. No asset user stuff. Don't pay attention to that. Just pay attention to what I'm typing, right? All right. So basically, with movement, we're gonna kind of base off what Luke made before in terms of how he made the movement. But I want to take a step further with the movement code, right? So instead of directly transforming it whenever a button is pressed, I'm gonna just save it to a variable. So I'm gonna name this variable vector3 and call this movement, right? And I'm going to set this equal to vector3.0, so we know that it's a 0, 0, 0 vector3, or it's just zeros in the movement, right? Now we can just go into the input and did what Luke did. So if input.getKey, keycode.a, if we press the A key or hold the A key, this will activate, and we want to do movement plus equal to. And with the movement, we want to make sure we want to go to vector3.right, right? So this is different from what you've been seeing Luke doing, but this is just another way you can think about how to do movement, how to store values, and how to kind of like make it all cohesive, right? So we have our A key, and we want to make it go left, actually. So instead of right, let's do left, and that's fixed. Now we can do that with all the other keys. If input.getKey, keycode.d, This will make us move vector 3 dot right. And then next we want to do if input dot get key code dot w. We want to make this go movement plus equal to vector 3 dot up. And then we can do this with input dot get key code dot s movement plus equal to vector 3 dot down. Oh, dot down. All right. So basically what I did here was I checked if the input is received. So if someone presses A, we have that movement right here that happens. And when an input gets received, they basically add a value to the movement value, and it kind of allows you to just condense everything into like one variable, so you have to move around. So does Unity still use vector 3 even though the project is 2D? Yeah, exactly. So that's something that I wanted to keep like in mind when we're developing Unity. All the positions, all the variables in terms of like rotation, everything will still be done in a 3D sense of a manner. So if I go back into the scene actually, and if I go 2D, you can see that our gun is actually just like a plane in this 3D world. And it still has all the positions of X, Y, and Z. It still has all the rotations of X, Y, and Z and scaling of X, Y, and Z. So if you really wanted to, we can move the player in the Z direction, but it does nothing. It does nothing because Unity ignores that axis for our 2D game, right? But that's something you want to keep in mind. When you're adjusting these values and everything, they will always be in a 3D 3D like storage of it. There won't be like a vector 2 used, but you can use vector 2s outside of Unity, Unity's default values. Like for example, if I want to store like speed for him to go up and speed for him to go left and right, you can do that in a vector 2 and then translate that to a vector 3. That's a good thing to keep in mind. Thank you. So let's go back to this. So we have this movement variable that basically stores our displacement that we want to displace a player. So when we press A, we want the player to go left, so we store that as a left displacement. And then if we want to go D, we want to go right, we store that as a right displacement, so on and so forth. Now, we want to basically take this value and did what we did with the old code and loose code in terms of just setting the position to this value. So instead of translate, we can just use this simple line of code, this dot transform dot position. So we get the position of the player, and then we add the movement to it. So basically, we're just storing all the values of the movement that we want to enter, and then we're applying it after the fact, right? We're not doing it as soon as we hit A, and then we're not doing it after the A, we could do D. No, we're doing it after the fact, right? So with this, I want to do just a quick like thing. Like Luke explained time to delta time and speed, we're going to do that same thing, right? So we want to make a public float, call this speed, multiply movement by speed, and then we can multiply movement by time dot delta time. So now this is basically what you saw in the old tutorials. We have speed delta time to move the player. So speed adjusts how fast the player is going, and delta time basically allows us to smooth out the movement and make it more based in our reality of per second instead of per frame, right? If you want a more deeper look on this, Luke explained this pretty well in his Unity Part 1 tutorial, so you can go ahead and take a look at that. All right, so we got our transform position and we got moving. Let's go test it out, shall we? So we have our player. I want to move at a like 5 speed. 5 sounds good enough. And then let's move back to 2D scene view. Let's go back to a gun, double click to go back to a gun. And then we see our gun, we press play. We move around with A, D, S, W, and there you go. We have movement back. Now, one thing I want to add on in terms of movement from Luke's explanation of movement is that when you're adding these values, there's actually something funky happening, right? When you press S, you're going down 5 meters or units per second. If you're pressing D, you're going 5 units per second right. If you're pressing A, you're going 5 meters or units per second left. But if I press 2 buttons at the same time, if I press W and D, it's actually going at, I would say, 10 around meters or units per second in the diagonal axis, because we're adding both the the A and the S together, or the W and D together, and it kind of combines the speed, right?
It's 5
So
root 2, by the way.
thank you so much, Luke. I can't remember the value. Awesome. So you can see that when you combine these two keys, it makes it go faster. This is a thing that a lot of old games may or may not have, but we can fix this easily, right? So I'm gonna do this real fast with one line of code. If you want a deeper explanation, I can give it to you. But the idea is we're basically taking our movement. You can imagine the movement as like an arrow in space, right? And the arrow has a direction and it has a length. We're basically taking the direction, keeping that same, and we're gonna take the length from whatever value it is and standardize it to 1 unit, right? If I press A, that will be 1 unit of time, but if I press A and W, that will be 2 root 5, I think Luke said, unit of time. And we want to standardize it back to 1 unit of time of distance, right? So what we can do for that is basically say movement dot normalized, right? And what this basically gives us is it gives us that 1 unit of vector length instead of the 2 units or however many units it was before when we press A and D. So if I save this, unpause, I play again. And now you see if I press A and D, S, W, nothing is affected. Nothing should be affected. But if I press W and D, you can see that we're going half the speed or roughly slower amount of speed. And it's all cohesively 1 unit. So this is something you want to keep in mind when you're making movement in general. Make sure you don't have that edge case where your player goes faster in one direction, right? So this is one of the ways to kind of fix that. So now we have movement going. Now we want the player to look at our mouse. How do we do that? Well, it's going to be a little more math heavy in terms of this. I'm going to go and make the code, but if you took geometry in high school, or if you're taking any like geometry or calculus in college right now, it's basically getting the angle of the mouse to the player and facing the player towards the mouse, right? It's that simple. So I'm going to just label this looking at our mouse so you guys know where we're at. And then we can make a vector3 mouse position, set that equal to input dot mouse position. So this is actually something that Unity provides for you. It's a way to basically get your mouse position of your mouse. Now this position is a vector3, like Flamebringer said. It basically allows you to get the X and Y, so you can use that on your screen, on your game. But there's something very interesting with this. If you debug.log this, so we can see the values of mouse position, it's actually not what you would think. It's not the world position per se, but if I press play, it'll give you a screen position, right? So you can see the bottom left values. If I go to this corner right here, that will be 0, 0 on your screen. That'll be the 0, 0 pixel on your screen. If I go on the top right here, that'll be like your max resolution of your screen. That'll be like 1400 by 700 right now, as is set right now. So the mouse position you get from input is actually a screen position and not the world position that we need. We can't really use this value in terms of a world position because, say, if we want to get a value when the player is moving somewhere, so if the player is here and we want that to face the mouse, it's not easy to get that angle, right? So what you need to do is basically go to 2D top-down shooter, go to our player controller, and we want to translate this. I'll keep the debug.log so you can see it. But we want to translate this from screen to world. So we can do mouse position equals camera.main.screen to world point. And we can provide the mouse position. So what this basically does is that it takes your camera. So our camera is this, our main camera. And it basically takes the screen position and gives you a world position for what's on what the current position of the screen position from the camera. That's really complex. Let me reiterate. So screen position for this will be 0, 0 right here, but world position will be 0, 0 right here. With this camera, we can take that screen position and move 0, 0 to right here with our mouse position. Right. So if I press save and press play so I can get a better look at what's happening, 0, 0 with our mouse right now is actually at where world 0, 0 is. Right. So you can see that in the bottom left where the debug's happening, we're closely roughly to 0, 0, And that's what we need. That's what we need for the player to look at the mouse. And if we go back to where 0, 0 was for our screen position, it's now someplace in the world, right? That's something exactly that we need and we want to use. And one thing to keep in mind, if the camera moves right 1 unit, the middle of the screen is no longer 0, 0. It's that position where the camera is looking at, right? So it just allows us to take the mouse position and put it into the world, which is something we need. So let's go back to the editor or the IDE. I don't know what it's called. And let's look at this code right here. Let's basically say, okay, we have our mouse position in the world, and now we want the player to look at the mouse, right? You can do this many ways. I'm going to do this the straight math way, so it gives us the most precise answer. There's also other ways that we can explain later on, but for now, I'm just going to copy and paste this code. I'm going to copy and paste this code in VC text chat if you want to use that too. But it basically gives us, let me just copy and paste this real fast. Da-da-da. It basically gives us the rotation angle that we need to apply to a player, right? So I'm just gonna copy paste this here. You can look deeper into this, how this works, but the idea is just taking our positions and getting an angle from it. And then now we have the angle. We can do this dot transform dot our angles equals to new vector 3, 0, 0 rotation degrees. So while copying that code down, I'm going to kind of explain what's happening here. So this dot transform, that Euler angles, is basically getting our angle of the player. So if you look at the Unity screen in the editor, and we look at our player, we can see that there's this rotational value, right? And what we want for the player to do is rotate around one of the points and look at the mouse. So the specific point is not X. That doesn't really do much. That just rotates us into 3D space, right? We don't need that. Y doesn't do much because that also rotates us in almost a 3D space, but you can't really see it. There you go. What we want actually is the Z axis, right? Now you can research more why you need the Z axis and what exactly angles is, but in order for us to kind of get the angle of the player to face the mouse, we need to adjust the Z axis, right? So what we're doing here is basically saying that we're going to take that Z axis and we're going to set that to our rotation that we need to face the mouse. Simple as that. So if I press play now, go to the game, press play. You can see now the gun is facing somewhat my mouse. It's a little bit off, but we can fix that, right? But it's overall, you can see that the gun is now facing our mouse, and that's exactly what we need. Let me go back into the editor and disable this debug log, so we don't need that anymore. And then we can go back here, and then we can go and fix this. So if we look at this again, and you can see that right here, my mouse is on the right side of the gun. It's facing the top side of the gun towards the right. So we can kind of adjust that in our scene. So let's move this right. And now, if we press play, it's facing our mouse on the right side. There you go. Now something that I'm going to do real fast is also, I like the right side to be to have the gun flipped in a manner where it's actually looking like you can shoot it and everything. So it's kind of flipped the right way. So when the mouse is on the right side, I want it to be flipped the right way. And this sprite render right here, there's actually a nice adjustment you can do. This flip X right here allows you to say, hey, I want to flip the gun on the X axis. I want to basically mirror it. So if I press this flip X, it adjusts it so it's the right way or the way I want it to be. Now this is really subjective because if you go to the left side, now it's flipped the opposite way, right? Wherever you want the gun to be located and how it looks, that's up to you. But I just wanted it to be flipped on the X axis so we can kind of get that like that standardized like right is forward type deal, right? So we can still move around and it still looks at the gun, the mouse. You can see, so WASD, move around, still look at the mouse. We're good with that. And now we basically have a nice movement and looking at input, right? So what do we want to do next? We want to shoot the gun. So shooting the gun involves something you guys haven't heard about before. It's called instantiating. But before we get to that, I'm gonna show you how to make a bullet, right? So let's quickly make our bullet. Let's go to the scene. Let's create, actually let's go to our sprites, go to cog happy, that's our bullet, drag and drop it onto the scene. And then now we have a cog happy bullets, right? I'm gonna rename this to bullet so it's more named properly. And you can see that we have a bullet, it's cog happy, and it's the same thing with the gun sprite. We just dragged and dropped in the scene, but we're going to also adjust it how we did with the gun sprite, as in it's a little bit too big. I want the bullet to be smaller. I want it to be more bullet and less like fireball, right? So I can go to cog happy, I can go to pixels per unit, and instead of decreasing this value, which will make it bigger, we're going to increase the value. So I'm going to do 200, see if that's good enough. It decreased it, but it's a little bit too small still. So I'm going to go to maybe 400. Maybe that's a good value. Perfect. Awesome. So now we kind of scaled our sprite without having to use the scale values over here, which makes our life so much easier in the end. But this sprite, whenever you drag and drop, it's now properly sized, right? So, okay, we have a bullet object. Now we need it to collide with something, right? So we need that collider again. Instead of a box collider, I'm going to use a sphere collider or a circle collider. Circle collider 2D, which basically fits the cog better than box collider would, right? So now you have this perfect circle shape that will actually fit the the cog happy. So we got collision, we got our bullet. Let's also make a script. So we can go into here, create a new script, call this bullet, and drag and drop onto our bullet. Now we have our collider, bullet, and renderer. I think that's all we need for our bullet. I don't think there's anything else from that. So before we actually go into making the bullet, let's think first. So in order to spawn this bullet and have it go off and do whatever it needs to do, but in order to spawn this bullet, we need to instantiate this bullet. So before we instantiate this bullet, we need to make this a prefab. So what is a prefab? So let me create a new folder so I can store this prefab. A prefab, you can kind of think of it as a saved game object that you can go back and use whenever you want. So if we take this bullet, check it down to prefab, now we have a bullet prefab, right? And now with this bullet prefab, we can basically delete this in the game object, and whenever we want the bullet back, we can drag and drop, and there you go. Our prefab spawned in the bullet that we need, and all the values, all the scripts, all the components, they're there for us. We don't have to worry about anything else. So that is what a prefab is in Unity. There's a little bit more to it, but I'm sure you can go and play with it and kind of see what else it has in store. So with our prefab, we want to spawn this, right? So let's go back to our player script. And we want to say, okay, I'm going to label section shooting our bullet. Happy face, right? So when we want to shoot our bullet, how do we do what again? The prefab? Yeah, okay. So in order to make the prefab, let's bring this in. Let's delete this. I'm just gonna undo everything I did. So just ignore what I'm doing right now. I'm just gonna unpack this. Oh, why is it not unpacking? Okay, anyways, it's fine. So in order to make a prefab, it's very simple, right? You just drag and drop it into the into like your files, right? Your assets folder, right? So in order to make a prefab, that's all you do. There's nothing more to it. There's nothing less to it. That's how you make a prefab. Does that make sense? Any questions with that? Awesome, great. So now we have our prefab. Now we want to spawn our prefab whenever you click, right? So what we do is we go into 2D, into our player controller, and we want to type some code in our update function of our script. If there are any changes made to bullet, there's already in prefab. Does the prefab save those changes, or do you have to put in a new bullet to prefab? Great question. So when a prefab is made, all the values stay the same, even if you adjust it inside the inspector right here. So if I click the prefab in the scene, and I adjust these values, and I go look at the prefab itself, that value is the same. See, the radius is 0.2, radius is 1.65. So adjusting it in scene, so inside the scene, will not change the prefab value itself. But in order to change the prefab value itself, there's two ways you can do it, right? You can go change the value you want, and then you can right click, apply to prefab bullet, so it saves that value. So go into bullet, it has that 1.39 value in there instead of the 0.2 whatever, or we can undo that real fast. Or we can adjust the size to whatever, to like 5.83, and there's a button over here that says overrides. If you can't read it, I'm just gonna explain it to you. It says overrides, and it allows you to choose what basically you want to change or apply to the prefab, right? So since I only made one change, I want to keep that change, I can press apply all. So now if I go to the prefab, that's all applied, right? So that's the easiest way to do it. There's also another way to do it, right? So if I go to the bullet prefab and I double click it, so if I double click the prefab, it opens this like blue void with only our bullet in the scene, right? So this is basically, if you can imagine it, your scene just for your prefab that you opened, right? So everything in here will be for your prefab and won't be for anything else in any scene. It will just only be for your prefab. So since our bullets are prefab, we can go in here and change the radius. And now after we change the radius, it automatically saves it for us since we're already inside our prefab and we're editing our prefab directly. So if you go into our scene, you can go onto bullet, and you can see that when we adjust our prefab, it adjusts the value in the scene. So it's almost like a one-way thing, right? So any values that change the prefab, change any prefab or references to prefabs in the scene, but any changes in the scene doesn't change the prefab in your files. Does that make sense? Any questions? No problem. If you have any other questions, just let me know. I gotta undo this real fast. There we go. Awesome. There we go. I hope I didn't undo too much. Oh, hi. Okay, I'm gonna delete both of these. So let's go back to what I was doing before. So in order to shoot a prefab or instantiate a prefab, we need to go to our script, go to our update function, and kind of type at the end of the update function. Give me 1 second, water break. All right. So in order to shoot our prefab, or in order to spawn a prefab, there's this fancy function called Instantiate, a function that I still can't really spell or easily spell even after using Unity for like 5 years, but Instantiate, right? So Instantiate basically allows you to take any game object, not just a prefab, but any game object in the scene and copy it. Or let me rephrase that. It allows you to take any game object anywhere, not even in the scene, just anywhere, and copy that into the scene, right? So you can feed this Instantiate function with like a lot of values. So if I can open this, you can see, oh, there's so many values here and everything. We're not gonna worry about that. We just want to copy our bullet prefab and put it into scene. So this method will do it for us. So we can do up here in the beginning of the class, we can create a public game object, and we call this our bullet prefab. So the reason we have this as a game object instead of like maybe a prefab object or anything like that is that prefabs, even in file, are still game objects. They're still one singular game object, right? So we don't have to have a specialized variable type for it. We don't have to have a prefab object type for it. We just have to have a game object type for it. So we have public game object bullet prefab, and that will store our bullet prefab once we go back to the editor. So we want to basically take this prefab and copy it into scene. So Instantiate will do that for us. So we do bullet prefab, and now it will instantiate into the scene, right? Before I press play and before I go back to the editor, I'm gonna basically make an if statement. If input dot get mouse button. So that's how you get a mouse input from your mouse. If the mouse button is 0 and is pressed, 0 is basically your left button. I believe 1 is your right button and 2 is your middle mouse button, and whatever numbers span that is whatever fancy numbers you have on your mouse, right? So 0 will be our left click. So when we left click, we'll instantiate this, right? So I'm gonna do that. Go back to our editor, and we're gonna go to our player, and now we have this bullet prefab game object field. We can drag and drop our bullet from the file. Make sure it's from the file and not from the scene. From the file, drag it over to a bullet prefab, and now this is referencing this prefab file in your assets folder, right? So we have our game object, we have our prefab, we're gonna spawn it. Let's try it out. We'll go to game, press save, press play. and we can click. And we can click. As you can see, there's a lot of problems with it. So first of all, we're actually testing when mouse is held down instead of when it's clicked, or when it's pressed once. So I'll change that. But it's not spawning where our gun wants to spawn. So how do we fix that, right? But you can see all our prefab objects are here, so that's at least good. So let's go back into the code. So first things I want to fix is the input. I want to make sure it's down instead of spamming it into the void and filling up our scene. We don't want that. We just want, when you click, it spawns a bullet. All right. But how do we adjust the position of this bullet prefab, or this bullet we're spawning, and put it to where our player is? Well, it's actually pretty simple, right? So you can do a game object, and we call this like our bullet clone, is equal to the instantiate. So what basically instantiate returns or gives you is the reference to the game object it spawns, the cloned object it spawns. So what we're doing here is we're getting that bullet clone, and we're gonna adjust some values on it, right? So the first value we want to adjust on it is bullet clone dot transform dot position is equal to, you can do this dot transform dot position, right? So we're basically copying our position and telling the bullet clone that, hey, here's our position, go to the position, right? So we go into our scene now, press play. You can see that when we click, oh, now it's actually following us. Very, very nice, very good. This is what we want to see. This is something that's great. Now we can go into making the bullet work, but also, yeah, actually no, we'll go into how to make the bullet. So let's make the bullet now, shall we? So we have our bullet. We can open this up in our scene and see the prefab, the bullet prefab. We'll have this open. And we can see our bullet script here. I'm going to just click edit script. So we can go into script and open it. And now we can start coding our bullet, shall we? All right. So our bullet, what do we want to happen? We want it to spawn and go in direction and kill something when it hits something, right? So let's still focus on bullet movement, right? So if public, we want the speed of the bullet, so public float speed. So we just want to keep that in mind. And we can do the code that we did for the last tutorial and the tutorial before that, in terms of moving an object around. We can use that same exact code, right? So we can do this dot translate, transform dot translate. So remember this function. This allows us to move our person or our thing, our transform, into a certain location, or into towards a certain location. So we do translate new vector 3 0 0, and then speed times time dot delta speed. So what I'm basically saying here, actually, I'm gonna not do that. I'm gonna do that here, right? So what's basically happening here is that I want to translate this bullet towards the x direction in the speed and time delta speed. We want to move in that direction at a constant pace. So every update will move this speed in that direction, in the x direction, positive x direction, every frame. So if you go into our game, we can go into our prefab. Make sure you're editing your prefab, not the scene, because it won't change clone bullets. So we want to change speed to like something medium. So 8 is a good speed, a little bit faster than a player. You know, something nice. We go into our game, press play, and then now we click. There you go. You got a moving bullet. Look at that. See, now we have a bullet. It's moving. That's great. But one problem, it's not moving in the direction we want it to move. We want it to move towards the player or outside the barrel, right? And that's not what's happening right now. So you might think, okay, I can change this in the bullet script, and I can do that in the bullet script, but we're going to simplify life, right? We're going to do this inside the player script, right? So if I go back to a player controller, and I go to when we spawn the bullet right here, what I can basically say is say this, right? I want to bullet clone dot transform dot Euler angles is equal to the new vector 3 0 0 rotation degrees. And I think I misspelled rotation. That's not a problem. I'll just rename it real fast. That will just bug me. Okay, so what we're doing here is we're basically rotating it where the gun's rotated, right? We're just copying the rotation. We're just using the same rotation, and since the bullet is translating in its local X direction, so when we move the bullet towards with the gun, it will move in that local X direction, which will be any angle towards the mouse. So more easy to visualize it if we go back into the scene, go back to the game, press play. And now we move around, and when we shoot, now the rotation, you can see kind of that the cog's rotating in its own way, but it's also facing the mouse, right? So that's exactly what we want. Now we have a bullet that's spawning and going towards the mouse and it's doing whatever it wants to do, right? That's exactly what we need. Now, one thing that you notice that I'm going to just fix real fast is that when you click and when it spawns, it stays spawned, right? That's something that we'll get to later on, but I want you to keep in mind that when you create an object, it will stay in the scene even if you don't want it to. So we'll fix that later on, but that's something that you can think about while we get to that point. All right, so now we want to basically say when the bullet hits something, destroy itself, and then we can focus on destroying an enemy later. When the bullet hits something, destroy itself, right? So I'm just gonna make a quick dummy to shoot at. So I'm gonna create a quick 2D object, my bad, sprite capsule, and this will be our dummy. It will have a capsule collider 2D, so it has something to basically react when they collide, right? I'm gonna name this our enemy dummy, right? So let's now save that, and let's basically say if I shoot the bullet, if the bullet hits that, the bullet will disappear, right? We want that to happen. Now, one thing I want to do is that with our bullet, let's go back to our bullet prefab. I don't want this to actually affect anything physically, right? So I'm gonna click is trigger, right? So is trigger will basically change the circle collider from something that will affect things in like the physics space towards like just something that will react and you can do whatever you want with it, right? So this won't collide or anything, and this is still too big. Let's minimize this to like 0.28. Yeah, there we go. All right. So now that we have is trigger enabled, this is similar to what Luke, I believe, did in Unity Part 2. So we can go to our 2D top-down shooter bullet script, and we can make a new function. This function will be called on trigger. Make sure you use trigger instead of on collider if you remember what on collider was, because on trigger will only activate when it's a trigger, and on collider will only activate when it's not a trigger, right? So on trigger, enter, and then since, like I said, remember, everything is 3D and we're moving into 2D space, we need to use the 2D version of on trigger, right? And you can press enter, or on your IDE or your editor or your script editor, you can just copy the codes if it doesn't automatically make it for you. But we have this method made for us, right? We have private void on trigger enter 2D collider 2D other. This basically will say, hey, when the bullet hits something, we're gonna trigger. We'll activate this part of the script, this function of the script, right? So what exactly do we want to do again? We want to destroy the player. So how do we destroy the player? Very simple. Destroy this.game object. So when this bullet hits something, we're gonna destroy ourselves. Very simple, right? So we save, go into back here, and let's press play, and everything will be great, right? So when we shoot, it doesn't destroy anything. Why is that? Well, in order for this function to actually activate when it hits something, there needs to be a rigid body, right? In some form of the equation, there needs to be a rigid body. So for us, we'll just add the rigid body temporarily or permanently to our bullet prefab. So if we go back to our scene, go to bullet prefab, add component, rigid body, 2D, make sure it's a 2D, not the 3D version. Select body type, kinematic. Now, this will allow us to have that trigger activate. The reason I set it to kinematic is because dynamic will allow this bullet to move how we don't want it to move. So that's why we choose kinematic. So the bullet will actually move how we want it to move, right? So we can press save. We can go to game, press play. And now when we shoot, it should destroy itself when it hits the dummy, right? Nope, not at all. Not even close, right? Because what's happening here is that it's actually colliding with the player before it hits the dummy. So it's like, oh, I hit something, let me destroy myself. How do I fix that, right? How do we make it so that it doesn't collide the player, but only collides with the enemy, right? This is pretty simple. So there's this thing in Unity, in physics Unity. There are layers. Ogres have layers, onions have layers, physics have layers, right? So with layers, you basically have your physics interacting with each other on different layers, and you can set layers specifically to different objects, right? So say I want the player to be his own layer, I want the enemy to be on its own layer, I want the bullet to be on its own layer, so that we have full control of what they hit, right? So bear with me, that it's a very simple example of what it is. So if I go to our layer, on our inspector, on anything, so we're just going on the bullet for now. You go to inspector, go to layer, and it'll say default. We don't want it to be default, right? In our bullet, we want to have our bullet layer. So how do we do that? So layer, default, I want to change it. I want to add a layer. You see how we have all these layers here? We can ignore them. We just want to add a layer, add our own layer. It'll pull up this inspector, and it'll pull up this list of layers, and with empty spaces that we can fill out our own and do whatever we want to do and name it whatever we want. So, like I said before, we want player, we want bullet, and then we want enemy. So let's write it down. User layer, player, user layer 7, enemy, and then user layer 8, bullet. So now we have our player, enemy, and bullet layers. Pretty good, pretty awesome. That's what we want. Now we go back to a bullet, click on the bullet and the bullet game object in our prefab. We can change the layer to our bullet layer, and ta-da! We have the player or the bullet on its own layer. And if we go in the game, nothing will change because it's a new layer we created, and there's nothing different aside from it being on its own layer, right? So let's continue throughout, and let's make all the objects in our scene on their own layer. Specifically all, but when I say all, I mean like the player and the enemy, and that's it, right? So player, put that on its own layer, player layer. It'll say, do you want to set layer to player for all child objects as well? If you see this, and you should see this. If you don't see this, make sure you're selecting the player game object and not the gun sprite game object. And if you see this, you can just press yes, right? So now our player is a player, and since that changed our gun sprite too, that's also a player. Now let's go to our enemy dummy. Let's go to layer, and let's go to bullet. Not bullet, I'm sorry, enemy. So now everything that we want on different layers is now on different layers. Now, what does this allow us to do, right? This basically allows us to do is basically saying, hey, physics engine, this is on this layer and this is on this layer, right? So we have object on layer A and we have another object on layer B. We can now define the fact that since object 1 is on layer A and object 2 is on layer B, we can say, hey, we don't want them to collide with each other, right? And don't register those collisions, don't register the trigger hits, don't register anything. Just make sure they don't hit each other. So how do we do that? We go to edit, top left of the screen, go to project settings right here, open that up, go to physics 2D. Let me maximize this so you can see. So we have physics 2D right here. Don't do physics. Remember, we're on the 2D section of Unity, not the 3D. So we need a 2D section. Same idea does apply to 3D. So if you're doing 3D and you want to do the same thing we're doing, you can think about it the same way. But more specifically, we want the 2D layers and everything. So as you can see, this is fancy like layer collision matrix as they call it, and it's like a triangle and everything, and it's a lot of checkboxes. It looks very complicated, but I can assure you it's very simple, right? So we want the player to not collide with the bullet. So how do we do that, right? You can see that player, there's a column of a column of player, and there's also a role player, right? We're just gonna focus on the column, right? So we find player on the column, there it is, and we want to say, okay, this player, we don't want it to collide with our bullet. So we find bullet. Oh wait, it's not there. Okay, since it's not there, we go to our bullet layer and see. Oh wait, is it there? And the answer should be yes. If it isn't, then you can look at it by rows. But let's look at our bullet column. Look down, look down, look down. Oh, there's player. If we unselect this, basically what this says is that the bullet won't collide with the player and the player won't collide with the bullet. So this is a way of for us to kind of easily filter out our objects in the game, right? So bullet doesn't collide with player, player doesn't collide with bullet. That's good. Also, I want to do something extra. I want to make sure when a bullet hits another bullet, it doesn't destroy each other, right? So how do we do that? We can look down, look down, look down, look down. Oh, there's a bullet too. So when bullet collides with bullet, nah, we don't want that. We don't want any collisions when bullet collides with bullet. So it'll allow you to do this since it will just basically disable collisions on the same layer, right? And this is just a way so you can say, hey, I want this object to not collide with this object, or I want this object to collide with this object, and it allows you to adjust that. So let's go back to the editor. Let's close this out. Let's save. Let's press play and go to our game. And now if we click, there we go. That's what we want. That's exactly what we want. When you click, we have the bullet spawn. It goes to the player or the enemy dummy. It hits the enemy dummy and disappears. Perfect. Very great. This is 100% what you need when it comes to shooting a gun, right? So now you look at this. You say, okay, when I hit the player, maybe I want a health system. Maybe I want to destroy the enemy. I'm sorry. Let me rephrase that. When we hit the enemy, not the player, when we hit the enemy, we want to destroy the enemy or damage the enemy. Now, in this tutorial specifically, we're not going to go into the health system. That's something you can look at in the future, and this is a good foundation for that. For now, we're just going to be destroying the enemy, and that's very simple, right? So we go over to our 2D top shooter bullet. All right, so on trigger enter 2D, we're going to destroy the scheming object, but also before that, I want to actually destroy the enemy object, or the object that we collide with. So how do we do that? On trigger enter 2D, collider 2D other, we can destroy other.game object. So basically, the other collider that we hit, we want to destroy it. We save this, we go back into scene, and I'm going to make a few of these so we have things to aim at, right? We press play. And we shoot. Ada, there we go. We destroyed our enemies. That's something that we want to see, right? All right. Have a good one, Luke. See ya. So that's basically what we want. We want to basically say, hey, when we shoot a bullet, we want to destroy an enemy. That's it. That's great. That's the gameplay. When we move around, shoot the bullet, hit the enemy, we are done with that, right? So now that we have our bullet and our player movement, we can move on to our enemies, right? So enemy, the way we're going to do that is very, very simple, very, very dumb of an enemy. So this won't use anything fancy. Like you can think pathfinding, you can think mostly pathfinding, you can think navigation AIs, you can think behavior trees. We're going to just not do any of that. We're going to create a simple enemy that follows the player and headswords the player. And when the player gets hit, the player dies and we lose the game, right? So how do we do that? First of all, just like a bullet, just like a player, we want to script that. We call this the enemy script. Go into it, and now we have our enemy script. Now, there's a few things I want to use when it comes to movement of the enemy, and that's the rigid body. I want to use the rigid body to move the enemy towards the player. So we want to reference that. So public rigid body 2D, make sure it's 2D, enemy rigid body. Right. So this is our rigid body, right? So we go back to this. And we go to enemy dummy. I'm gonna destroy all these enemies. I'm going to enemy dummy. I'm gonna add the rigid body 2D. I'm gonna add the script, or I'm gonna add the enemy script, or enemy script. There we go. And I'm gonna drag this 2D body onto the enemy rigid body. Now we have a reference for that in the script. One thing I'm also gonna change is that we had that ghost image, right? We did have that ghost image. So I want to use that as our enemy, right? So I'm gonna just search up for ghost, select that. And that's a small little ghost. Now, that's a little bit too small. We want to make that bigger, right? So how do we make that bigger? We want to do the same thing we did with the gun, right? 32 pixels. Since this is a 32 by 32 image, apply. Now we have our our enemy. It's also a little bit blurry. Let's clean it up, remove the point filter. Colors look wonky. I'm going to remove the compression. Ta-da! We got our enemy. We can save this, go to your game, and there's our enemy. Let's also adjust the collider, because the collider was meant for the capsule before and not enemy. So we're going to just click edit collider, drag that down, drag that up. Oh, I keep missing because these buttons are so small. Drag that up, drag that inwards, drag that inwards. Move that up a little bit more, and ta-da, that's our enemy collider, right? So that's what our capsule collider will look like when it wants to hit something, right? So let's go back to our enemy script. And like I said before, we want the enemy to move towards the player, right? So how do we do that? Well, basically, if you know anything about vector math, which I don't expect anyone here to know anything about vector math, vector math is very nice. It allows you to basically get a distance or difference between you and the player, and you can use that in funny ways, right? So let's do vector 2. We will call this vector 2. We will call this, or actually, no, let's make this a vector 3. My bad. Vector 3, call this our difference, right? And we're going to basically subtract player.position. Oh, that's not thing. Oh yeah, I did forget something. Sorry, my bad. One thing that we did forget is that we want to reference the player somehow. We want to get that position, so we can do public game object and player. So whenever we want to reference the player, we can just set that in our editor and have fun, right? So player, so let me do that again. Vector 3, difference equals player dot position, or dot transform dot position, minus this dot transform dot position, and that'll kind of give us like a arrow, like if you think about it in an arrow point of view, an arrow from us to the player, right? So kind of the direction we need to go and the distance we need to go towards the player. So we can go enter, and now we want to basically move us towards the player. So how do we do that? We can do this dot enemy rigid body dot add force. Now this is a fancy way of just saying I want to push the rigid body, which is a physics object, towards the player. And the force we need to provide is a vector 2. So this is where 3D and 2D kind of gets a little collision, right? So vector 2, you want to cast, right, your difference from a vector 3 to a vector 2. Now this will basically remove the z-axis and just give you a xy of what the other values are. I just want you to keep in mind, when you do 3D or 2D to 3D, you can't do it this way. You have to create a new vector 3 and then set the values yourself, because when you cast a vector 3, vector 2 to a vector 3, you add that z-axis, and there's a lot of worries with, like, do you want to set it to something? Do you not want to set it to something? So you can't do this, what we call cast, right, from vector 3 to vector 2. So we got our vector 2, we want to cast it over, and this will basically add force for the player every update towards the player, or for the enemy towards the player. Now I want to do the same thing. I want to do public float speed, so we can get speed, multiply this by speed, also multiply this by time of delta, just so that everything is, reasonable and we know how it works. Go back in here, go to our enemy script, make sure we select gun sprite, or not gun sprite, I'm sorry, player, drag it to our player so it has a reference to what the player is. Our speed, let's make this slower or faster, let's set it to like solid 5. But same speed as the player, but in fact it will actually act differently. So you can see what happens when I press play. What did I mess up there? So you can see that the enemy is actually going rogue. So what happened there? Let's look back at our script. Nothing happened there. Actually, the problem that happened there was that this is using gravity still, and we're on a top-down shooter. We don't have gravity, we just have a top-down view. The only gravity that's happening is from us towards the screen, and we don't see that gravity, right? And so in order to remove that, this gravity scale, make sure that's 0, press save, press play, and ta-da! It's now moving towards the player very, very slowly. I'm gonna increase the speed to like 10, and then press play again. So, oh, my bad, I shot it, my bad. I'm sorry, Ghost, I didn't mean to harm you yet. So what happened here? Basically, when I set the speed to 5, you might think, okay, it's only gonna go to 5 units per second towards the player. But in fact, adding force, like I said, is pushing the ghost or the enemy towards us at a force rating, not a speed rating, right? So, in fact, actually, these are two different values. When I say speed for enemy and versus speed for player, they're two different things. So, because When it comes to enemy and rigid bodies, you don't have that same addition of position, right, that we did with player. All right, so great. We have our player, we have our ghost, and it wants to go towards the player, and it's missing every time. I believe actually, does it hit the player? There it goes. It hits the player too. See, very fun, very nice. And you can see that it comes back even though it's spinning, and that's exactly what we want to see, right? So now we want to basically say if the ghost hits our player, we lost the game. Game's over. No more game, right? We're not gonna distract health. We're not gonna do any of that. We're just gonna say no game, right? So oops, I don't know what happened there. Oh, that's what happened there. Okay, I went to the wrong editor. So what we can say is basically on. Actually, that's good. We can say on collider. Did I misspell? Oh, on collision. My bad. Enter and make sure it's a 2D collision, not the 3D, because this is 2D only. Press enter. Create our method. On collision, enter 2D. We want to say, hey, if we hit something, we lost the game. So, actually, we don't want to say, hey, if we hit something, we lost the game. We have to more specifically say, hey, if we hit the player, we lost the game. Now, how do you do that, right? There's many different ways to do this. I want to just elaborate. There's tags. There's testing if it has a component. There's just making sure it's the same game object. There's a lot of ways. I'm just going to say, hey, if our other .game object, the game object that we hit, .name is equal to player. This is the least inefficient way, or the most inefficient way to do it. But I'm just going to do it so it's more easier to say see. So if the other game object .name is equals to player, that means we hit the player, right? So we can say debug.log game lost. And then maybe we can also do something fancy, like, for example, time.scale or time.timescale equals to 0. So what time.timescale is doing is basically saying, okay, so you see these time.delta times here? Yeah, we're not going to provide you anything, or we're going to scale that by the time scale, right? So if you had 1 here, this will be normal. If you have 2 here, this right here will be twice the delta time. If you have 0, this will be 0, right? So it's just basically multiplying this delta time under the hood. So you can say, I want to freeze time by just doing time scale equals to 0. Now, if you look at the demo, some things didn't get frozen because there's more things you got to worry about than just time. So just keep that in mind when you're pursuing this yourself, right? So we save, we go to the editor, we press play, and when we get hit, I'm just gonna let the ghost hit me, ghost. It froze, and I can not move around because my movement is based on time.delta time, but I can still shoot because shooting is not based on time.delta time, right? But you can see game lost, and that's a game, right? So if you press play, you can move around and say, okay, I want to shoot the ghost, I'll kill it. Or you can press play, say, oh no, there's a ghost, I'm gonna run into it. You lost the game, right? That's the 2D top-down shooter gameplay that we're looking for. And it's very, very basic, very, very simple. Now, with this, we want to have it so that it's just not one ghost, but multiple ghosts spawning. We want all the ghosts, So how do we do that? First things first is that with enemy dummy, it's not a dummy anymore. He's a ghost. We're going to name it enemy ghost. With our enemy ghost, we want to make a prefab of the ghost, right? So prefab, drag and drop into our prefab folder. And now we got enemy prefab, right? Now we want to spawn our enemy using the enemy prefab, and that's going to be done just by another script. So go to the scripts folder, create a new C# script, and we call this enemy spawner, right? Open this up, and I'll wait for anyone that's still writing stuff down. And enemy spawner. So what do we want enemy spawner to do? All right. So if you can imagine this scene, if we go back to player, enemy spawner, we want him to spawn the enemy around the screen, around 0, 0 of the screen, right? And in order to do that, we're just going to say, okay, we're going to make a circle, and like say this is a very rough mouse circle, and then we're going to spawn within the circle. We want to spawn the enemy anywhere within the circle. Now, Unity has something fancy that we can use for this, and we want to also make sure it's random too, which the thing I'm about to use for Unity also does that. So I'm just creating a new function just so that we can control this, and we don't want to spawn ghosts in every frame. So void spawn ghost, right? So, or I'm going to make this spawn enemy so it's more generic, right? So I want to spawn an enemy. So how do I do that? First, we need the prefab. So public game object enemy prefab, right? And we want to instantiate the enemy prefab. And now we have a prefab. It'll do the same thing. It'll just spawn to the scene in whatever location it spawns in, and only that location. We want to change it, right? So game object enemy equals instantiate enemy prefab. And we want to change enemy.transform.position is equal to, now this could be where the fanciness comes in, right? So how do we get a circle? How do we get a random circle? How do we get a random position in a circle? Where? Well, it's really simple. You can do random dot inside unit circle, and Unity gives it to you. It's pretty simple, pretty nice, pretty easy, right? Now this will basically give you a unit circle. So what a unit circle is, if we look on the screen, it's basically going to be the size of this player, right? So the radius is going to be 1, and it's going to be somewhere inside this. Now we want it to be anywhere on the screen, so we can just multiply the this unit circle by a spawn radius. So public float spawn radius multiplied by spawn radius. Oops. And now if we look in the scene, that spawn radius will basically transform a circle of whatever my mouse is hovering around to whatever scale we want it to be. So how do we do that? So we can go into our inspector, click create a new empty object, and we can call this our spawning object, right? So we'll spawn our ghost for us. We can add a component, and we can add our enemy spawner. And now with our enemy spawner, we can select our prefab. So we'll set that up with our ghost prefab and our spawn radius. Now the spawn radius is pretty nice. Like I said, it will scale it to anything we want it to be. So 0 would be just, it will only spawn into 0, 0 because it will be scaled to 0, 0, and the size of the circle will be nothing, right? So let's say we wanted to spawn in a 10 radius. So it will spawn maybe like 10 units this way, and then that'll be the circle, right? So we save this, we go back into here, and we can say if input.get key down, say if I want to press the space bar, key code .space. So every time I press the space bar, we spawn our enemy, right? So every time I press the space bar, we spawn an enemy, and I'll run this function with the code inside. Pretty fun, very easy. Press save, go into our editor, press play, and now I'm gonna kill this ghost so it doesn't kill me. Whenever I press space, you can see they spawn everywhere. They're just spawning, but wait, hold up, they're not moving. Why aren't they moving, right? That's pretty simple. So you can see if we spawn something and we go to enemy ghost, you can see that we click on enemy ghost. Oh wait, it doesn't have a reference to player game object anymore. Why is that, right? Why doesn't it have the reference to a player? We set it to a player before we made the prefab. It should have a reference to a player. Well, that's actually something funky with prefabs, or pretty tame with prefabs. When we go into our enemy ghost prefab, you can see that, oh, the player's not referenced. Why is that? It's because, remember how I said the prefab is one scene, its own scene, and everything can only reference everything inside the prefab, or whatever values you need. The player is not in our prefab scene, because why would it be, right? Our player is in the game scene. So the thing that it wants to reference is not where it needs to be. So how do we fix that? Well, we can just basically say, okay, we can go to our spawning game object. We can want to declare a public game object, player object. So that'll be our player reference. And we just want to set it manually every time the enemy spawns, right? So when we spawn an enemy, we can go to enemy, our spawn enemy function, say enemy dot get component with our with our left and right arrows, and say I want to grab the enemy script from the enemy, right? So this will grab the enemy script from the enemy, and we can say enemy this script. I mean, now we have all the access that we need to the whole script parameters and properties. You can see that there's a player field. That's the thing that was missing something, right? So we can say player is equal to player object dot. That's it, right? There you go. Now, whenever we spawn an enemy, it will have a reference to player. When we press play, you see, whoa, look at that. It's not spawning because I forgot to set the spawn player object. So let me do that. Let me select that, move that over. Now, if we press play, let me spawn. There you go. Now we have all these enemies. They're coming towards me and I can shoot them. And that's part of the gameplay. Now, we're missing a few things. For example, we don't want to press space to spawn enemies. We want them to spawn automatically. How do we do that? Well, we can say, okay, in our enemy spawner script, we want to create this nice tool that is not a Unity tool, it's a C# tool. So if you think about this tool, it's just C# general, but this tool is called the Stopwatch, right? So if we do public Stopwatch, and we call this our spawn Stopwatch, is equal to new Stopwatch. So we create a new instance of the Stopwatch, and we can import it. So the import would be system diagnostics. This stopwatch is basically our stopwatch that we need to use. It will keep track of our time, and it will simplify how we're adjusting time. Now, you don't have to use this. I'm just going to plant this right now in your mind that you can use time.delta time to keep track of time. You figure that out on your own time, but we'll just use this so it'll kind of simplify how we think about our time, right? So we want a stopwatch, right? We want a stopwatch. We want to say when it's 5 seconds, or X amount of seconds. So we'll do that. Public float, and we can say, let's say, I'm trying to think, what's the variable name for it? Name is hard. Spawn time, and we will set this in an editor. So when the stopwatch reaches spawn time, we'll spawn the enemy, right? So first things first, the stopwatch, it has to start running sometime. So in order to make it start running, you can do stopwatch dot start, and we do this inside the start method. So whenever the game starts, it will start the stopwatch, and that's what you want. And then in the update, instead of if input dot get keyed down, we can say if spawn stopwatch dot elapsed milliseconds. So this could be in milliseconds. So remember that spawn time will also be in milliseconds. If elapsed milliseconds is greater or equal to our spawn time. So if we've reached or passed the point, which is possible, we could pass the point of our spawn time of when we wanted to spawn. We want to spawn the enemy, and we want to restart the stopwatch so it will spawn again for next time, right? So this is a nice way to keep track of time, and whenever you want to spawn something periodically, this is how you can do it. So if we go back into our editor, we set spawn time to say like 1,000 milliseconds, which is just 1 second, right? 1,000 milliseconds is 1 second. We press play. See, now it's spawning every second, a enemy, and there you go. That's what you want to see. That's great. And you can see it's spawning, it's going towards the player, and we have a gameplay. This is technically the completed gameplay loop, but there's only a few adjustments we need to make now, right? But we got our game. It keeps spawning. That's our game. So what do I mean by there's a few things we need to change? First things first, as you see, these bullets that are in the screen, they're staying there. They're not disappearing, and that's not good for us. If we keep shooting and we miss, it'll just stay in the game. And if you shoot like 1,000 bullets and miss 1,000 bullets, it'll stay in the game, and it'll clutter up our game speed, our performance, our frames per second, whatever you want to call it. It'll just clutter that up, and we want to clean that up. So how do you clean up the bullet? We can go to bullet.cs, and we'll do the same thing. Public stopwatch, and we call this our lifespan stopwatch equals new stopwatch, and then we can create a public float. Or let's do int, because the milliseconds, to be honest, are only recorded in ints. There's nothing past it, past there. So we'll just do an int or longs, whatever variable type you want. This is something that you decide. But we'll do int for now, integer, public int, lifespan, and then we'll set that in editor. So we'll do the same thing. If lifespan stopwatch, we're gonna start it up in the start method, and if we reach the spawn, or if we reach the lifespan, we can destroy this game object. And I missed, and lifespan stopwatch, I missed the, yeah, so actually before, I'm gonna make this elapsed milliseconds. So in order to use Stopwatch, you need using system.diagnostics. This right here. I'm gonna zoom in a little bit. System.diagnostics right here. You want that to be your value or your import. Since this is not a Unity thing, this is a C# thing. So you can just type in using system.diagnostics. I'll copy and paste this for you. There you go. All right. So now we got our game. Let me just fix the zoom. Actually no, this may be easier to read. Now we got our bullet. We save this. We go back into our game. Press play. And now when we shoot, it disappears automatically because we forgot to set a value for a time. So when lifespan is, let's say, it'll stay in the screen for 5 seconds or in the game for 5 seconds. So when I shoot, you see on the left side, our bullets spawn in. And then if I stop shooting, wait 5 seconds, the bullets disappear. And now we don't have infinite bullets being like kept in the screen, right? It's really nice. Another thing we want to add is that someone provided us with a quick background. Very nice, very interesting. We're just going to add that real fast. So we can just drag and drop that into the screen. Since this is kind of pixel arty, I'm going to compression, none. Filter mode, none. And I want to set the size of this. I want to increase the size. So I want to set pixels per unit. Let's set it to like 32. Apply. Oh, that's big. Okay, maybe a little bit smaller. Let me 64. There we go. Maybe too small. Let me do like average 48. Sure. There you go. So now we got this background, nice fancy background on the side. And I want to mention something now. Now that we have this background, I want you to know something. That with this background, we didn't really define any layers or anything where if a ghost spawns, it might spawn behind the background, so we can't see it. So this is a fancy thing in Unity, right? This is called this in our sprite render on our object, on any sprite object, you have order in layer, right? Basically, order in layer is a way to say, okay, if you want an object or image to be rendered, it'll be rendered from the least layer to the highest layer, right? So everything of a lower value will get rendered first, and then everything of a higher value will be rendered on top. So, for example, if I do order in layer to 1, you can see everything disappears because everything defaults has a order in layer value of 0, right? So we want to set this to a negative number, so like -1. So now everything with order layer of 0 will spawn on top of the background. This is something that a lot of people run into that I've seen in the club and in general, where you spawn something and it doesn't spawn and you're questioning yourself like, hey, why isn't this spawning? Where's my object? What am I doing? Well, it's basically because it's being hidden behind the background, right? That's one of the reasons. That's mainly a reason, especially if you don't know that order in layer exists. So I want you to keep that in mind when you're doing this, right? So now we can press save, press play, and I think we have our game. I think that's it, right? So this game we can lose. We lost right there. They spawn enemies. We can move around and we can shoot our enemies, and that's a gameplay loop in itself. This is pretty fun. You can have like enemies that go around. They can bump into each other. They can like try to follow you, try to hit you. They're ghost enemies. It's pretty nice. One thing I want to change is that sometimes these enemies may have like a hard time turning towards the player, or not turning, but like moving towards the player. I'm gonna reduce this mass so it can move easily. I'm gonna reduce it to like 0.3. So it's balancing the game a little bit, right? So now when I move in a certain direction, it'll move easier towards me, right? So you can see it's not having a hard time anymore. And I just ran into an enemy. All right, so that's our game. That's basically what a 2D top-down shooter can consist of. But I want to reiterate that yes, this is a 2D top-down shooter. This is a game. You submit this as a game. It's great. But there's a lot of edge cases and problems that you might run into, and you might want to think about to fix. I'm gonna list the things that you probably will run into, and you probably want to fix, and I'll give a pro and con. And if you want a deeper insight of it, just say something in chat, and then I'll answer that. Right. So, for example, one major issue that we have right now is that if the bullet's too fast, it will actually not collide with anything. right? So there's two ways to fix this. If you go into bullet or bullet prefab, there's these collision detection section right here, this field. You can select this as continuous. So what this basically means is that this will continuously detect for movement and continuously detect when it needs to collide or something, and then interpolate. You can select this to interpolate, and it'll basically say it will kind of smooth itself towards that position. Now, this will kind of solve your solution of when a bullet's too fast. So in this scene, I'm going to create a quick square. So okay, imagine this bullet. Oh shoot, that's not a good way to examine this. Actually, I'm going to the scene, create a new bullet. So okay, imagine. All right, this is our bullet. We need to hit our ghost. If it's going every frame, if it's going 5 meters per second or X meters per second every frame, it can skip over, right? So say I'm going here, I'm skipping over, right? And if this happens, it basically means that the rigid body just skipped over and it didn't hit it, even though the coast was in its pathway. So one thing you can use to fix this is called raycasting. And more specifically, you can raycast between your previous and your current point to see if you get hit. Now, that's the depth. I'm gonna go into that. But if you have this problem where your bullets are too fast and it's phasing through enemies, or the FPS is too low where it's moving jittery, and it will phase through an enemy, think about raycasting. Think about raycasting as using like a way to detect, hey, in my path did I hit anything? All right. So that's one of the problems you might run into. Another problem that you can solve that you might run into is that I'm spawning a lot of bullets. For example, I'm not going to be able to show this on my computer since I kind of have a powerful computer. No, that's not a reason. But if I spam bullets like this, I'm spam clicking. I'm using a macro to spam click. I'm not actually holding down a button. Eventually, your FPS will start to get lower and lower and lower and lower, especially if you don't have a good computer, right? If you don't have a good computer and you have all these objects on screens and I'm just spamming, your FPS will go down, 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 and whenever you need to destroy something, it'll lag, and whenever you need to spawn something, it'll lag. In order to fix this, think about object pulling. Now, object pulling is the idea of, say, hey, I want to spawn an object and I want to destroy an object, but instead of spawning and destroying an object, what you can do is basically say, hey, I want to grab from this object pool, I want to grab this specific object from this object pool, and I want to bring it to the game, and then when I destroy it, instead of actually destroying it, I put it back to object pool, and I can reuse the same asset over and over and over and over instead of keep spawning and destroying, spawning and destroying. And if you want a more technical point of view of why that would lag your game, just think about the fact that doing that is faster. Like grabbing from pull, enabling, and then disabling and put it back into pull is faster than instantiating and destroying every single time you need to do that, right? Doing an object pull will kind of increase performance. Now, don't use that. Think of that as like an optimized feature. So don't inherently use that whenever you need to, or whenever you don't need to. Use it when you need to, right? All right. So that's object pulling. Another thing is in our script. In our script, we have our stopwatch, right? Now, like I said, the stopwatch can be done in so many different ways. It can be done with time.delta time. It can be done with just a stopwatch, or it could be done with your coroutine, right? I'm not going to explain much about what a coroutine is. You can search it up, find tutorial videos, see what it does. But basically, a coroutine is a way, or it allows you to kind of time your codes, right? So instead of having this if statement or anything, you can just say, I'll wait 5 seconds in this coroutine and then I'll spawn, right? So definitely use coroutines as a thing that will assist you in terms of timing or waiting for something in your game, right? So that's a fancy feature you can use. And then let me see, do I have any other features that I want to explain? Let me pull up my notes here. Let's see. And the health system, right? So the health system, you can kind of base it off of what you have here. So you have your bullet on trigger enter 2D. Instead of destroying, you can grab the component for a health system and subtract values for the health system. Now, this is something you could do on your own, but this basis of code will allow you to do that in a way, right? I'm going to adjust this. All right. So that's basically all I have to go over. There's a lot more things that you can think deeper in, like customizing enemies, customizing bullets, customizing your player. There's a lot of things to go deeper in. I'm not going to do that. This is a simple 2 hour, less than tutorial of how to do a basic game, create a basic game, right? So if you have any questions or anything that you want me to go deeper into, just say it right now, and then we'll go into it. If not, we'll call it a day, right? So if you want anything, if you want to see more of anything, just please say in VC text chat. No, nothing at all. Going once, going twice, three times, and sold. All right, cool. Awesome. So, I hope everyone enjoyed this tutorial. We'll be doing similar tutorials like this, like bite-sized games, bite-sized systems, maybe using art programs, using other things. If you want anything specific, please just message us and say, hey, I want this, and then we'll see if we can add it to curriculum, right? But for now, you will see more of these types of things where we'll recreate certain game mechanics or games or creating assets or maybe project structure or things like that, right? So other than that, thank you guys so much for coming. It really means a lot that you guys are learning about game development. It's really a great field to go into in terms of just having the creative and technical aspect combined all in one area. And I hope to see you guys in the next workshop. But other than that, have a good one. Thank you for coming. We'll see you next time. Bye, everyone.